Have you ever found yourself with a bunch of data and all you really want is a simple answer, a yes or a no? Questions like, will this customer click the ad? Or is this transaction fraudulent? Well, there's an amazing tool built for exactly this, and we're going to break it all down today. It's called logistic regression.
So to make this all feel real, we're going to focus on one single question from start to finish. Based on things like grades and test scores, will a student get into their dream graduate school? It's the perfect yes or no problem for us to solve together.
And here's the data we're going to play with. We've got info on 400 different applicants. For every single one, we know if they got in. That's the admit column. A 1 means, yes, they got accepted, and a 0 means, nope, better luck next time. We've also got their GRE scores, GPA, and the rank of their undergrad school, with rank 1 being the most prestigious, like an Ivy League.
Now you might be thinking, hey, can't we just use linear regression for this? Just draw a straight line through the data? And, for predicting something like the price of a house, that works great. But when you're trying to predict a simple yes or no, well, a straight line gets us into a little bit of trouble.
Here's the core of the problem. A straight line can just go on forever, right? It can predict a value way above 1 or way below 0. But we're predicting a probability, the chance of getting in, and that has to live between 0% and 100%. What does a 120% chance of admission even mean? Or a negative 10% chance? It's just nonsense.
So that's the big puzzle. If a straight line is the wrong tool for the job, how in the world do we build a model that understands the rules and keeps our predictions locked between the logical boundaries of 0 and 1?
The answer is actually a really clever idea called a link function. The best way to think of it is as a special kind of translator. It takes the normal output from a linear model, which can be any number, big or small, and it translates it into the language we actually need. In our case, the language of probability.
And for logistic regression, our translator is this awesome S-shaped curve. It's called the logistic function. And look how it works. It doesn't matter what number you feed it, a massive positive one, a huge negative one, it just squishes it so that the output is always a sensible probability between 0 and 1. It's the perfect solution.
All right, now that we have the right tool in our toolbox, let's actually put it to work. We fed all our data into the model, so let's check out the report and see what it has to say about our grad school hopefuls.
Okay, here it is, the raw output. I know, it looks like a big, scary wall of numbers. But I promise it's not as intimidating as it looks. We're going to break this down step by step until it makes perfect sense.
The first thing you need to look at, the most important part, is this estimate column. These are the coefficients, the real heart of our model. They tell us exactly how much things like GRE, GPA, and rank matter. But there's a catch. These numbers aren't speaking English. They're speaking a statistical language called log odds. And this is absolutely crucial. When you see that 0.80 for GPA, it does not mean your probability goes up by 80%. What it actually means is that for every 1 point increase in GPA, the log odds of getting in go up by 0.80, which is pretty confusing, right? What even is a log odd? So this is our next mission. We have to be translators. We need to take this weird statistical log odds language and convert it into plain English so we can get some real-world, meaningful insights out of it. And lucky for us, there's a really simple 3-step recipe to do this. First, we find our log odds coefficient in the table. Second, we do a quick calculation to turn it into something called an odds ratio. And finally, we just have to interpret what that odds ratio actually means for our students. So what is this odds ratio? It's just a multiplier, that's it. It tells you how the odds of getting admitted change. If the odds ratio is 2, it means your odds just doubled. If it's 0.5, your odds were just cut in half. See? So much more intuitive. Okay, let's put this recipe into action. Remember the GPA coefficient was 0.804? We take e to the power of that number and out pops 2.23. The translation, for every single point a student's GPA goes up, their odds of getting into grad school more than double. That is a massive, massive effect. Now, let's do the same for the school's rank. The coefficient for coming from a rank 2 school compared to a top tier, rank 1, was negative 0.675. We do the math, and the odds ratio is about 0.51. This means a student from a rank 2 school has their odds of getting in cut almost in half, just because of where they went to school. Wow. And what about that GRE score? Its coefficient was super tiny, just 0.002.
When we convert that to an odds ratio, we get 1.002. So what this tells us is that, yeah, a higher GRE helps, but not by much. Every extra point only bumps up your odds by a tiny 0.2%. So, we've decoded the numbers, we've translated the model's secret language. It's time to circle all the way back to our original question and deliver the final verdict. According to this data, what's the real key to getting into grad school?
The story the data tells is crystal clear. GPA is absolutely huge. It's a major driver of success. Where you did your undergrad is also critical, giving a big advantage to students from those top-ranked schools. And the GRE score? Well, it's not totally useless, but it is way, way less important than the other two.
So let's just quickly wrap up the key takeaways about this whole process. You use logistic regression for any yes or no question. It works by modeling the probability with that cool S-curve. The model spits out coefficients in log odds, and your job is to translate them into odds ratios. And remember, an odds ratio over 1 is good news, and under 1 is bad news. Simple as that.
And really, that's it. That's how you go from a simple question and a table of data to a powerful, predictive model. Now that you've seen how it all works, the real question is for you. What are the yes or no questions in your work, in your hobbies, or in your life that a tool like this could help you finally answer?